Hello students, and welcome back to another algebra video. You know what to do. Pause the video and think about these problems on the screen. What do you think a function is? Do you know what a function is? Have you heard of one before? What do you think a function does? Have you heard the words domain and range before? If you have, what do you remember they mean? If you haven't, what do you think they mean? Think about all of these questions as you pause the video and then unpause it. And we're actually going to talk about all of these things in our video today. As you may have guessed, we are starting chapter 3, and chapter 3 is all about functions and specific types of functions, but today we're just going to introduce you to functions and what are functions. So, our learning target and success criteria for today are: you know what a function is. And how will you know if you know what a function is? Well, you'll be able to determine whether a relation is a function, and you'll be able to determine a function's domain and range. A relation is a pairing of inputs with outputs. Now, that might seem kind of unfamiliar, but basically an input is: what are we taking? What do we know? What information am I given? And then what gets done with that information? So, we could have a relation for anything. We could have a relation for how tall you are. Maybe there's a relation between how tall you are and how much you weigh. Or maybe there's a relation between how many books you have and the grades that you get. We can look at relations between many things, but the most interesting relations are functions. So a function is just a relation. It takes how many hamburgers you order and it gives you the price of the meal that you are buying. Whatever the relation may be, and it pairs each input with exactly one output. That's really important. A function takes each input and pairs it with exactly one output. So, I like to think of a function as a box. You give it an input. Now, in our case, our functions are going to be equations. Our inputs will be numbers. Our outputs will also be numbers. So you can think of a function as a box. You give it an input, some number, and it spits out an output, or some number. The way that I kind of think about functions is when you go to the grocery store, every item has a barcode, right? This cup has a barcode. And when I scan that barcode, a price comes up on the register. So our input is that barcode, and the output is the price. Now, if I scan this cup's barcode, can I get two prices? Can this cup cost $5 and $7 at the same time? Well, no, of course not. This cup costs $5 or it costs $7. You're not going to make me pay $5 and $7 for the same cup. That doesn't make sense. So functions take one input and give you one output. So you can think of it like scanning barcodes at a store. Now, in our case, in algebra, we're not going to talk about barcodes and prices. We might in a word problem, but more generally, we are going to look at equations and numbers, because we can use equations and numbers to model real world situations like barcodes and prices. Okay, so a function takes each input, each barcode, and pairs it with exactly one output, one price. So if you give me a cup, I will get one price. And if you give me a number, I will get exactly one number. If you input -2, I should only get -6. I should not also get 0. No, no, no. One input, one output. One number for your input gives you one number for your output. Okay, now these are some examples of a function, but those might not make a whole lot of sense now, and that's okay. We're going to talk about those in our first example. Determining whether relations are functions. Determine whether each relation is a function and explain. Now, something we didn't mention in the last slide is that your inputs are going to be your x values. Your outputs are going to be your y values. And this is very helpful when we do problems like this. So, I'm going to write that right at the top. X is the input, and y is the output. Okay, now, the easiest way to do these problems for me is I have a hard time separating. I know that the x-coordinate comes first. So in all of these points, I know the first number is the x-coordinate, and the second number is the y-coordinate. I know that, but what does that mean in terms of a function? Remember, for a function, I want each input, or each x value, to be paired with exactly one output, or one y value. But how can I see from just a list of points, how can I see if we're getting exactly one output or not? Well, here's what I like to do. I like to make a box of my inputs. And that was not the prettiest box. There we go. I like to make a box for my inputs, and I make a box for my outputs. This helps me see. These are the barcodes that I'm taking. These are the prices that I should be getting, or whatever your function does. If it takes barcodes and gives you prices, or it takes, other inputs, gives you different outputs. So I'm going to put all of my inputs, or all of my x's, in the first box. I have -2, -1, 0, 1, and 2. Awesome. I just pulled those right from the points that they gave us. Okay. Now, I'm going to put all of the outputs, or the y's, in the second box. So we have -2, 2, and those go together. So I'm going to draw an arrow. If you give me -2, if that is the input, I get +2. So I'm going to draw an arrow between those because they're from the same point. Okay. Next, -1 went with 2. Oh wait, those are the same number. So how about I just put 1, 2 here, and both of them can point at the same 2. It doesn't matter if you want to draw 2 separate arrows. Doesn't matter. I think this is fewer numbers to write. Okay. And now we have, we have 0, which points to 2. Okay, lots of things pointing to 2. All right. And now 1 points to 0, and 2 points to 0. Okay, so now we are asked to determine whether this is a function or not. Well, does every input have exactly one output? Remember, that's what it means to be a function. Every input has one output. Well, -2 has one output, 2. -1 has one output, 2. 0 has one output, which is 2. 1 has one output, which is 0. And 2 has one output, which is 0. Okay, so this might look a little confusing to you because, wait a minute, all of these numbers are pointing to one number. But that's okay, right? This cup can cost the same amount as this calculator. They can have the same price, as long as we're not talking about one item having 2 prices. 2 items can have the same price. That's fine. But one item cannot have multiple prices. So what you don't want to see is if this 0 was also pointing to the 0. If one number is pointing to 2 different numbers, that's not okay. Because now I have one item with 2 different prices. And that's not okay. That doesn't make sense. Okay, so part A is a function because each input has exactly one output. And that's all you need to say. Now, part B also gives us some points to look at. So, let me erase the arrows and the numbers that we have here, and let's just do part B with the same boxes. So if you need to, pause the video so that you can redraw another set of boxes in your notes, and then unpause it and let's continue the problem. I have my x's come first, so I have 4, 8, 6, 4. Oh, 4's already there. We won't write it twice. 4's already there. And 5. Okay, awesome. And my outputs, or my y's, I have 4 goes to 0, 8 goes to 7, 6 goes to 4, 4 goes to 3. Okay, so 4 also goes to 3, and 5 goes to 2. So notice how each pair of numbers, each point with the x and the y, the x points to the y. So x is 4, y is 0, and the 4 points to the 0. So that's how we're making these diagrams right here. Okay, now we're done. We put all of the points. We have the x's and the y's, and we have the arrows connecting them. Is this a function? Part B is or is not? What do you think? Part B is or is not a function. What do you think? Pause the video and think about it for a second. Unpause it, and let's notice that the input 4 is pointing to 0, but it's also pointing to 3. So remember, that's one input. 4 is one input, but it is pointing to 2 different outputs. It's not okay. That's like this cup having 2 different prices. It doesn't make sense. So part B is not a function because 4 has 2 outputs. It's pointing to the 0 and the 3. So part B is not a function. Okay, we're gonna need more space here, so let's move on to parts C and D. And actually, I'm gonna move myself over to this corner so that we have enough space to do parts C and D, and you can see them without me being in the way. Okay, so we did parts A and B, that's good. Now, let's look at part C. So notice how we can look at relations as a set of points, we can look at them as a table, and we can look at them in the 2 boxes with arrows that we've been doing them in for the last 2 examples. So you can see relations in many different ways. Okay, so let's look at part C. Now, they already have input X, output Y. They already have it there for us. But for some of you, it might be easier to see this in the box format that we've talked about. So let's draw 2 boxes. Let's take our inputs, or our X's, and let's put them in our first box. So we have -2, -1, 0, oh, 0 again, so I won't write that one twice, 1, and 2. Okay, and now we see -2. If I have the input of -2, I get -3. That's why the -2 is right on top of the 3. So -2 points to 3. And -1 points to 4, because the 4 is right underneath the -1. 0 points to 5, and 0 also points to 6. 1 goes with 7, and the 2 is right on top of the 8, so 2 goes with 8. Okay. And our outputs are our Y's, of course. Now, is this a function? Part C. Is it a function? Well, I notice that 0, one input, is pointing to 2 different outputs. And that's not okay. Not for a function, it's not, because 1 cup shouldn't cost 2 different amounts. So, part C is not a function because the input 0 has 2 outputs. And that's not okay. Not okay for functions. All right, and our last example, well, they already put it in the way that we like to see it, right? They have the inputs, they have the outputs. So we don't even need to redraw that. Let's just zoom in on it, and let's take a look. We have -1 goes to 4, 3 goes to 15, and 11 also goes to 15. So, what do you think? Part D is or is not? What do you think? Is part D a function? Yes. Part D is a function. Because every input has one output. -1, 4. 3, 15. 11, 15. One input, one output. If this -1 were also pointing to the 15, then we would have a problem. But remember, two numbers can point to the same number. That's okay. Two items can cost the same price. That's okay. So part D is a function because each input has exactly one output. There you go. There you have it. Okay, let's see if we were right. Determine whether relation is a function. Relation is a function. Relation is not a function. Relation is not a function. Relation is a function. Oh, and let me move my head back over here so we can see part D. So the relation is a function if we have one input gives us one output. All right, next thing we're going to talk about today is the vertical line test. And we'll talk more about why this works later. But for now, the vertical line test in words means a graph. So now we're talking about graphs. Before we looked at points, tables, and diagrams. Now we're talking about graphs. And how do I know if a graph is a function or not? You use the vertical line test. So a graph represents a function when no vertical line passes through more than one point. Okay, that's the words. What does that look like? Well, if I draw a vertical line, I should not pass through more than one point. So look at the graph on the left. If I draw a vertical line, I only hit one point. There's not a second point up here. I'm not hitting 2 points. I'm only hitting 1 point. But if we look at the second graph, if I draw a vertical line, I'm hitting 1 point? I'm hitting 2 points. Now you might argue, well, what if I hit it right here? Then I'm only hitting 1 point. But it doesn't matter. If you can draw one line, vertical line, if you can draw one vertical line that intersects at 2 points, it's not a function. It doesn't matter if you can draw a line that only intersects at one place. It doesn't matter. If you have one line that intersects in 2 places, it's not a function. And that's because, so say this is 1, 2, 3, and this is 1, 2, 3, 4. What we're saying here is that the 3, which is the x or the input, is going to 2, and it's going to 4. That's what we're saying. That's what the vertical line test is saying. Is it saying, hey, if you draw a vertical line and it crosses in 2 places, you have this. You have one input with an arrow that goes to 2 different outputs. And we know that's not okay. That's like 1 cup costing 2 different prices. That doesn't make sense. So that's why the vertical line test works. Okay, let's move on to our next example using the vertical line test. So, we want to determine whether each graph represents a function and explain. Well, how do I know if a graph represents a function? I use the vertical line test. So, Can I draw a vertical line that hits more than 1 point? Well, if I draw this vertical line, I only hit 1 point. Okay, that's okay. Ooh, but if I draw a vertical line here, uh-oh, I hit this point and I hit this point. So, not a function. Because it, oops, and I'm drawing behind my head. It doesn't pass the vertical line test. It fails. If I draw a vertical line, it intersects at 2 points. And that's not okay. Okay, part B. If I draw a vertical line, I intersect at 1 point. If I draw a vertical line, I intersect at 1 point. Intersect at 1 point. Intersect at 1 point. Is it possible to draw a vertical line that intersects this graph in more than one place? Can I draw a vertical line that will intersect this graph in more than one place? No. No matter how I draw my vertical lines, I'm only ever intersecting at one place. So, this is a function because it passes the vertical line test. And there you go. Graphs are a little bit easier in my opinion because it's just vertical line. Does it hit once or does it hit more than once? Okay, let's check and see if we were right. You can draw a vertical line through 2 points, so the graph does not represent a function. And no vertical line can be drawn through more than 1 point. So, it is a function. Yay, we were right. Okay, all right. Now, we're going to talk about domain and range. So this is the last thing that we're going to talk about today. Now, the domain is all of the input values. So, the domain is what we are putting into the function box. We talked about the function box earlier. All of the inputs, that's your domain. So all of your x values. And if this picture is not in your notes, definitely put this in your notes. Because my x values are my input values, which make up my domain. So x, input, and domain should all be right next to each other in your brain. The range of a function is the set of the output values. So the output values, or my y values, make up my range. So, domain, input, x should all be right next to each other in your brain, and output, y values, range should all be next to each other in your brain. Okay, great. I know my domain is my inputs. I know my range is my outputs. What does that mean? What can I do with this information? Well, I'm so glad you asked. We can find the domain and range just by looking at a graph. Now you might wonder, why is this helpful? We're going to use this more later, especially in advanced algebra trig, and if you move on to pre-calc, we're going to use it there. You're going to keep using it. So let's jump into example 3. Find the domain and range of the function represented by the graph. Well, remember, domain is my inputs and the range is my outputs. So what they're asking for when they say find the domain is what they mean is they want you to list what are the numbers in your domain and what are the numbers in your range. So it's kind of like the boxes that we made with the arrows before. What is inside of your domain box and what is inside of your range box? So let's zoom in on this graph a little bit. In order to know what my inputs and outputs are, I need to know what my x's are and what my y's are. Because remember, my inputs are my x values, my outputs are my y values. So we need to figure out what is the x and the y of each of these points. So the first point, we'll look at the top right point first, and that is at 3, 4. The next point is at 1, 2. The third point is at -1, 0. And the last point is at -3, -2. Okay, now let's take the x piece of each of these points. So 3 goes to 4, 1 goes to 2, -1 goes to 0, and -3 goes to -2. And I'm sorry, typically we make the outputs blue, so let's do that. 4, 2, 0, and -2. So that you can see the blue numbers are the y values of your points. So that's why we have 3 pointing to 4, because 3 is the x coordinate and 4 is the y coordinate. Okay. Now, when it asks you to find the domain, find the range, you don't need these arrows. It doesn't care about the arrows. If it asks you to find the domain and range, you just need to say, this is my range, this is my domain. The end. You don't need any arrows. If you want to put the arrows there to practice what numbers, what inputs go with what outputs, go for it. Go for it. Okay, but there you have it. There's your domain, there's your range. Now, at this level, we're going to look at the domain is only 4 numbers. As you get into advanced algebra and pre-calc, your domain is going to look a little bit more complicated. And speaking of a little bit more complicated, we're going to look at a tiny bit more complicated in part B. So now, I still want the domain and the range, but now, wait a minute. In the first example, I had points. I had 4 points, and I could find the x's and the y's of those points. In the second example, there's only 2 points, but there's a line in between them. How am I supposed to find the coordinates of every single point on this graph? That's a lot of points. Do I have to do that? No. No, I do not. So, in part B, when we have a solid line connecting points like this, we're not going to break it down into the coordinates of every single point. That would be too much. Instead, what we're going to do is we're going to look at all of the x values together. So what I mean by that is let's look at the x-axis. The x-axis is the horizontal axis, the one that goes from left to right. And what we're going to ask is what is the smallest number on the x-axis of our graph here? So let's see, we have -1, and we have a point at -2. Do I have a point at -3? Oh no, the graph stops at -2. So the smallest number I can have in my domain, which is my x values, the smallest x value I can have is -2. Okay, that makes sense. Now, what is the biggest x value I can have? Let's see. I have 1. I have 2. I have 3. Do I have 4? Oh, there is no point at 4. So 3. The graph stops at 3. So the biggest number I can have in my domain is 3. And because my domain is talking about my x values, what we say is that x, or the input, can be anything in between -2 and 3. So you'll remember this from chapter 2. What this means is x is greater than or equal to -2, but less than or equal to 3. Or x is in between -2 and 3. And if we look at our graph, we can see that. X is in between -2 and 3. These are all of the x values on our graph. And there you go. That is your answer for the domain. In part B, we have a set of numbers as our domain. Well, actually, in part A, we also have a set of numbers. But we have an inequality set of numbers in part B. Okay. Now, let's look at our range. Let's look at the y values. And actually, I'm going to use a different color for the range, since the graph is blue. I don't want to use blue, that might be confusing. So let's erase all of the x-axis, x input stuff, and let's go ahead and look at our y values. And to look at the y values, we're going to look at the y-axis. The y-axis is the vertical axis that goes up and down. And what we're going to say is, what is the smallest number on the y-axis that has a point on it? So if I look at 0, I have a point. If I look at -1, I have a point on my graph. If I look at -2, do I have a point on my graph anywhere? No, this is just empty space. There are no points next to -2. No points. So, -1 is where the graph stops. If I'm looking up and down, remember for the y values, I'm going to be looking up and down. So the bottom of the graph is at -1. That is the smallest y value that I have for my graph. The bottom of the graph is at -1. Okay, so that's the smallest, and I know that my y values need to be bigger, or need to be above -1. But where do they stop? Where do they stop? Let's see. I have a point at 1. I have several points at 1. And I have a point at 2. Do I have any points at 3? Nope, just empty space. So 2 is the top of the graph. And you can see that the whole graph is in between -1 and 2. All of the blue line of our graph stays in between -1 and 2, excuse me. So the biggest we can be is 2. And there you have it. Our domain is -2, is all the numbers in between in between -2 and 3, and our range is all the numbers in between -1 and +2. Okay, let's check and make sure that we were correct. We have all the inputs are the x coordinate of the points. All the outputs are the y coordinates of the points. And look at this. The domain is from left to right. The range is up and down. The domain is, same inequalities that we got. Awesome. Woohoo! Well, there you have it. What I'd like you to do at this point in the video is ask yourself, do you have any questions? And if you think like, well, I'm confused, but I don't have any like specific questions, here's what I want you to do. Think back to our learning target and our success criteria. Do you know what a function is? Can you determine whether a relation is a function? And can you determine what a function's domain and range are? Rate yourself on a scale of 1 to 3, where 1 is, I have no idea what's going on, 2 is, I don't know, and 3 is, yes, I understand it perfectly and I will ace my homework. Rate yourself. How well do you understand the learning target and success criteria? Are you a 1? Are you like, I don't know what's going on? Are you a 2 where you're like, some of it makes sense? And are you a 3 where you're like, oh my goodness, everything makes sense. This is wonderful. If you are a 1, it is time to reach out to your teacher, go to after-school tutoring. If you are a 2, now is the perfect time to try your homework and see if you can move that 2 up to a 3. And if you're a 3, well, hey, consider reaching out to your friends and saying, how are you doing? I understand the homework. Do you need any help with it? So, use this time for questions to assess your own understanding of our lesson today. If you would like them, here are some practice problems. Let me get rid of my head for a second so that you can see everything on the screen. Here are some practice problems that you can try if you would like to practice the skills that you have learned in this video. And of course, let's end with our launch. So today's launch comes from Helen Keller, and she says, keep your face to the sunshine, and you cannot see a shadow. And think about that. If you're keeping your face towards the sun, and the sun is pointing at you, your shadow will be behind you. So if you're looking at the sun, your shadow will always be behind you. If you're looking away from the sun, you're going to be able to see your shadow. So if you don't want to see shadows, you need to keep your face to the sunshine. Now, what does that mean? What might that mean? Well, if I'm looking at the sunshine, if I'm looking at the good things, if I'm looking at the positive things in life, that's why we do good things every morning, to focus on the positive. And if I am focusing on the positive, I can't see the shadows. I can't see the negative. And that's not to say that maybe you can't know that they're there. We know our shadow is there, but we're not focusing on them. We can't see it. And that's where, if you're grateful for what you do have in life and you're focusing on the good things, life is so much better than if you're constantly focusing on the shadows. If you think, wow, I'm so thankful that I get to go to school, I get to see my friends, I get to learn new things, I get to learn new things so that I can do something productive with my life, I can get a good job and have a wonderful family and support that family. Those are really happy thoughts, really empowering thoughts. But if you think, wow, school is so boring, people have nicer clothes than me at school, I just feel bad about myself when I go to school. If you're focused on those things, of course you would be sad and life would not be very happy. So if you focus on the positive, you'll be more of a happy person. Now, is it as easy as saying, oh, I'm going to focus on the positive, immediately I'm happy? No, you have to practice. This is something that you have to practice. focusing on the good is kind of hard to do sometimes. So if you find yourself focusing on the bad, don't beat yourself up about it. That's going to make you feel more sad, right? So don't beat yourself up about it. Just go, oh, notice it. Oh, I'm focusing on the bad things. Now let me focus on the good. I'm going to change that. The bad things are there, but I also have a lot of good things in my life. So practice focusing on the positive. It will become easier and easier to focus on the positive, and you'll be more of a happy person. So that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.